Everyone, I think we're going to go ahead and get started. Welcome to our first installment of our Rutgers Equine Science Center Fall Webinar Series. We're really grateful that you all took the time out of your out of your evenings to come meet with us tonight. And we have a great talk ahead for you. My name is Jen. I am a graduate student, a Ph.D. candidate here at Rutgers University. I work with Dr. Karyn Williams on her pasture research, but I also work with Dr. Malinowski and Kyle at the Equine Science Center. And I'm going to be your host for tonight. We're going to ask everybody to use the chat function if you have questions. So make sure you know how to type into the chat. If you have questions as you go along, throughout the talk, there's going to be some breaks where Dr. Malinowski is going to stop and take questions. So I'll be monitoring the chat, and Kyle will also be monitoring the chat for your questions. So we'll make sure that we bring those to her attention when she kind of calls for questions at the break. So if you have any questions at any point as we're going along, feel free to type them into the chat. And then I'd also like to introduce Kyle, or to let Kyle Hartman introduce himself to you. Kyle's our PR specialist here at the Equine Science Center. So if you'd like to introduce yourself, Kyle.
Sure. Hello, everyone. Welcome to our first Equine Webinar Series from the Equine Science Center. We're really looking forward to it. We have a great lineup of presenters, starting with our director, Dr. Karyn Malinowski. If you have any questions throughout, like Jen had mentioned, Jen will kind of field some of those questions and pass them along to Dr. Malinowski, anything related to the presentation, and I will be here for any technical questions that you have. So if you have any difficulties or anything along those lines, please also put those into the chat. You can direct them right to me, or if you're okay with everyone seeing them, you can just leave it set to everyone. There is that setting if you want it to just come to me. So welcome.
All right, thank you, Kyle. So then I'm going to introduce our speaker for this evening, Dr. Karyn Malinowski. Dr. Malinowski, an accomplished equine scientist, is the founding director of the Rutgers Equine Science Center at the New Jersey Agricultural Experiment Station. She has served as a faculty member at the School of Environmental and Biological Sciences since 1978 in various roles. These include as an extension specialist in the equine sciences, an animal sciences professor, founding director of the Equine Science Center, and director of Rutgers Cooperative Extension. Her research and extension programs concentrate on improving the well-being and quality of life of the equine athlete while ensuring the vitality and viability of the equine industry, both statewide and nationally. She played a lead role in building the equine science program at Rutgers University and in the formation of the Rutgers Equine Science Center. Dr. Malinowski is a recipient of many awards, including the American Society of Animal Science Equine Science Society Equine Award in 2012, the United States Harness Writers Association Unsung Heroes Award in 2012, Governor's Trophy for Horseperson of the Year in 2010, Rutgers Graduate School Lifetime Achievement Award in 2007, Outstanding Equine Educator Award from the Equine Nutrition and Physiology Society in 2001, Marjorie Van Ness Award from the American Horse Council in 2001, Research Excellence Impact Award from Cook College and NJAS, and Woman of Distinction from the Delaware Raritan Girl Scout Council in 2000. In 1995, she became only the second woman in 50 years to receive the New York Farmers Club Award, which was given by the prestigious and venerable Northeastern Agricultural Society to her for her contributions in agriculture. Dr. Malinowski is the author of over 50 refereed journal articles and abstracts and numerous book chapters. Her expertise in the area of aging and stress management in horses has resulted in her speaking at numerous international venues, and her extension project entitled Careers in the Green Industry, Youth Sow Seeds for Their Future, which involve horses and educated youth, has served as a model for similar programs around the globe. Malinowski was a member of the team which conducted the prize-winning study, the New Jersey Equine Industry 2007 Economic Impact. She also led the effort in developing the Horse Industry Handbook during her presidency of the American Youth Horse Council from 1992 to 1994. Regarding teaching and graduate student mentoring, in 2008, Dr. Malinowski developed a new 2-day winter session course entitled Developing Future Leaders for the Equine Industry. The course is geared towards individuals working to become involved in New Jersey's equine industry. Dr. Malinowski is a full member of the Rutgers Endocrinology and Animal Biosciences and Kinesiology and Applied Physiology graduate faculties, advises independent research for 4 to 6 undergraduate students per semester, and served as major professor for 2 postdoctoral fellows, Dr. Charlie Kearns and Dr. Riel Christensen, 2 Ph.D. candidates, Ryan Avenetti and Ellen Rankins, 3 master's candidates, Cynthia Betros, Patrick
Rinaldo,
and Christina Rusnello, and served as a committee member for 6 doctoral and 6 master's candidates. Dr. Malinowski led the industry effort, which resulted in the New Jersey Agricultural Experiment Station receiving, beginning in 1992, $1.2 million annually for strategic initiatives from the state legislature. The Equine Science Program received $300,000 per year from this allotment until 2010. In 1997, the excellence of the Equine Science Program was recognized with a $267,000 bequest from the Doris C. Murphy Estate, and in 2015, an $835,000 bequest from the estate of Gwendolyn E. Stableford. Dr. Malinowski has also raised in excess of $1 million in private donations for use by the Equine Science Center. In 2013, she procured lab equipment and supplies valued at $225,000 as a donation from the New Jersey State Police Drug Testing Laboratory. So thank you, Dr. Malinowski, not only for all of your achievements and contributions to the horse industry, to the state of New Jersey, and to, of course, Rutgers over the years. And we're excited to have you here to present on your work in aging in horses. So at this point, I'm going to turn everything over to Dr. Malinowski. And again, if you have any questions, feel free to put them in the chat. Thank you.
Thank you, Jennifer. Thank you, Kyle. And welcome, ladies and gentlemen, as we continue in these tough times to deliver our mission of better horse care through research and education to ensure the well-being of equine athletes and that of the equine industry, not only in New Jersey, but beyond. Those of you who have been following us since March know that under Kyle's leadership, we began an initiative called Keeping Safe While Keeping Engaged. This was every Friday, a group of archived podcasts, webinars, fact sheets, etc., around a theme. And every Friday, these were posted on our website. Launched on August 4 was our new equine trivia for kids evening, starting at 7 p.m. every Tuesday night in August. This is an initiative of Jennifer's, and it has been great fun and a great test and challenge for all of us. And I'm very pleased to be able to kick off this webinar series this evening. And this will go every other Thursday night, culminating with our Ask the Experts panel, which will be live on November 5th. And then we also, ladies and gentlemen, will be doing our Evening of Science and Celebration in a virtual format. So that will be on November 12th. So with that, I welcome you all. I'm going to be sharing with you probably 25 years worth of research that's been conducted here at Rutgers and with colleagues at the University of Kentucky. And so let's hope, Jen, I can just share this screen. And there it is. Mazel tov. And we are going to start the show from the beginning. Oh, I guess I have to type slideshow from the beginning. Here we go. Whoop. Okay. Thank you. And again, we have at Rutgers probably know more about the aging process in horses than any institution in the world. My colleagues, Ken McKeever, beginning with Sarah Ralston, my postdoctoral fellows, and also including Carrie Williams in this as well. We have been studying the aging process in horses for about 25 years now. And so I will be sharing with you tonight some results of that research. And again, guys, there is a take-home message in each part of this, this research. And so there's a reason why we are doing all of this work. It's not just to find out about what happens to the horse as it ages, but our bottom line is to ensure good health and well-being in our older horse population. So people might ask, including the administration at Rutgers University, why do we study old horses? Who cares? And if we look at the latest National Animal Health Monitoring System survey, NAHMS, in 2015, it was estimated that over 11% of the equine population in the United States is over the age of 20. Now, there are over 9 million horses in the United States, so 11% of that is a significant number of animals. And interestingly, when we were discussing the development of the most recent NAHMS survey, which was conducted in 2015, we chose the age of 20 plus because our research has told us over the last 25 years that really horses don't start to show changes due to age until they are around 20 years of age. Now, so there are a lot of older horses in the United States. Many of these animals still participate in athletic and reproductive activities. And so we have pictured here the fabulous Olympic gold medal winner in dressage, Graf George, who was in his late teens when he received this gold medal. Pictured here is the great show jumping mare, Sapphire, who was 16 when she won her Olympic gold medal. And we have pictured here the fabulous thoroughbred stallion, Seattle Slew, who in his 20s was still breeding mares and siring foals. So if we look at athletic activities, you know, when you talk about Olympic athletes, many of these horses mentally aren't ready to compete at that level until they are in their late teens. And so anything that we can learn about their well-being and taking care of them at that age is of benefit to them. And there is limited published data on the effect of age on the integrative physiological response to both acute, short-term, and chronic or long-term exercise and its importance to the quality of life of that horse. And we also asked the question, and we know the answer to this now, and you will learn this evening: when does a horse actually get old? And we need to answer that question based on science, not just on guessing. So I'm going to take you through a brief review of the literature of what we know in both humans and horses. And we know that aerobic capacity in humans, or what we call VO2 max, decreases with age, unfortunately. And there are also changes in muscle fiber profiles and body composition. As we people get older, we tend to carry more fat in our body, a percentage of body fat, and we also tend to lose that muscle tone. Humans also have impaired thermoregulatory ability, the ability to deal with heat. And so we've all heard in the last couple of weeks when we're going through this unbearable heat time through July into August, check on your senior citizens and your elders because they are not able to thermoregulate as well as younger people. We also know in humans that there are aging and training-induced alterations in the endocrine or hormonal control of both metabolism and energy homeostasis. And there are also aging-induced changes in cardiovascular function. Now, what do we know in horses? And pictured here, ladies and gentlemen, are two of my favorite old-timers. I love them both. Pictured, the equine in the picture, the horse in the picture, is Lord Nelson, our beloved Lord Nelson, who is our mascot for Equine Science for Kids. He recently passed away at the age of 42. In this picture, Lord Nelson is about 32 years of age, and he is being ridden by his owner, Tom Manos, who in this picture was 82 years of age. And so Tom is still with us. He's watching us this evening, and so love you, dear. But it was wonderful to be able to see Lord Nelson and Tom enjoy the outdoors and each other in their elder years. So in horses, we know, like humans, aerobic capacity does decrease with age. There are aging-induced changes in cardiovascular function. There is, like in people, an impaired thermoregulatory ability in the older horse, and some of the work that Bob Leonard did in conjunction with Ken McKeever, there is a change also in body composition. We also know that from the hormonal side, there are aging and training induced changes in the hypothalamic pituitary adrenal axis. And some elegant work, some of which I will share with you later on in the presentation, in Dr. Horohoff's lab, our colleague from the University of Kentucky's Gluck Equine Research Center, and his former Ph.D. student, Amanda Adams, who now is on faculty in the vet science department at the University of Kentucky. They actually demonstrated that there is a reduction in immune function with age, something that we call immunosenescence. And Dr. Horohoff years ago coined the phrase inflammaging, which is an increase in inflammatory cytokines or overall body inflammation as we get older or the horse gets older. So we're going to share some of that data with you in a little bit. Dr. Adams and her student, Mandy Vick, and Dr. Liebert, who is a PhD graduate of our program here at Rutgers, we have shown over the years that exercise training, conditioning over a long period of time does increase insulin sensitivity. It reduces inflammatory cytokines, and body condition actually does respond to training. And Dr. Liebert also demonstrated that energy homeostasis is altered with age. There's reduced insulin sensitivity, there's reduced insulin secretion, and pancreatic beta cell function. And here's a picture of our dear Lord Nelson actually enjoying one of his favorites, a hot dog. Again, Mandy Vick in Dr. Adams's lab has demonstrated repeatedly that chronic inflammation is one of the major contributing factor to the loss of insulin sensitivity in horses. This is important to know. You know, we talk about equine metabolic syndrome and insulin resistance. This chronic inflammation is the major contributing factor to this loss of insulin sensitivity. And Nick Frank and his co-workers at Tufts Veterinary School has demonstrated that insulin resistance in horses results in equine metabolic syndrome, the loss of muscle mass. This, what we see pictured here, this abnormal deposition of fat in different places, and also the dreaded disease of laminitis. So while insulin resistance, what we call diabetes in humans, is not a condition that we want to have, insulin resistance in horses also is detrimental to the horse's overall health and well-being. However, we know that training, exercise training and conditioning in horses does alter the insulin response to both short-term acute exercise, and it also improves insulin sensitivity, which is a good thing. This is what we want. And Cindy Beatros's work demonstrated that with exercise training, you can increase VO2 max and the velocity at VO2 max in the older horse. However, we'll share this data with you in a minute. Young horses definitely have a more robust adaptive response to exercise conditioning. And we have yet to elucidate in equine tissue the molecular adaptations to exercise. And a PhD student of Dr. McKeever and me at Ryan Avenatti. We will not share that data with you this evening in view of time, but all of Ryan's work in heat shock proteins has actually begun to elucidate the molecular adaptations to exercise in equine tissue. So those of you who have joined us before at the Equine Exercise Physiology Lab, you kind of know the routine, but I'm going to share our experimental protocols with you. This is what we've used over the last 25 years during our experiments. We usually use unfit standardbred mares. Body weight is about 1,000 pounds. We have experiments with 2 age groups, ladies and gentlemen, but we also focused on a group of studies with 3 age groups. The young group, the mean age was 7 years of age. The middle age group was 15, right around where Sapphire and Graf George were, our teenagers. And this group of horses, this old group of horses, included a 30-year-old standardbred mare. The mean age was 27. So these horses actually were very old. They were accustomed to the lab, the treadmill, the equicizer, and all of the tests. And we conducted a graded exercise test before and after training. The graded exercise test is depicted here. We begin on the treadmill and we use a 6% grade, so the horses do not have to go as fast. They are on an incline. They begin at a walk at 4 meters per second for a minute. We then increase the speed to 6 meters per second for an additional minute. This is a slow trot. And then every minute we increase the speed 1 meter per second until the horse reaches fatigue. And fatigue is a point where the horse cannot keep up with the treadmill despite humane encouragement. And VO2 max is depicted here. It's a point where there are no further increases in VO2 despite increases in speed. So a horse may reach VO2 max, let's say here, at about 120 milliliters per kilogram per minute of the exchange of oxygen, but this horse can hold this on for a couple more minutes at that, even with increasing speed, even though it has already reached VO2 max. For the training, most of the trials that we've conducted consist of 12 weeks of exercise training and conditioning. These horses were trained in our motorized exerciser. We can have 6 horses at a time. They were all grouped based on speed at 60% of heart rate max. And this is about what, when you are conditioned at the gym yourself, you like to condition yourself at about 60% heart rate max. These horses were exercised 3 to 4 days per week. There's a warm-up and a workout for 10 minutes in each direction for up to 30 minutes, and the speed was adjusted weekly based on heart rate. One thing I want to share with you all is these horses in all of these 3 groups loved this exercise. When we came in the mornings, they were waiting at their respective gates in their paddocks, waiting to come in and to do their exercise. And while their peers were exercising, they were all standing there by the fences watching. And I must also share with you that the grouping of the horses on the equicizer were not just based on age. So we had several young horses. I remember a 3-year-old who was lazy and did not want to train. She was in a group that was the slower group, where Chablis, the 30-year-old trotter that we had, was in the elite top group. So again, mental attitude and physical ability certainly dictate how well these horses performed, but every single one of them over the 12 weeks improved. So now let's get to some of the data I want to share with you. And this is the first study of exercise capacity in young and old female horses by Dr. McKeever and myself. One table here, ladies and gentlemen, this is a group of 2 groups of horses. So we had a group of young mares, which averaged 5 years of age, and the mean of the old mares was 22 years of age. So again, 15-year difference, horses over 20 and horses around 5. As you can see, their weight did not differ. Their resting VO2 did not differ, but look at VO2 max. The young horses, the VO2 max in these young mares was 117, and in the old mares, 89. Now, so there definitely is a significant reduction in aerobic capacity in the older horse. But what I want to share with you is that even in old age, the horse has an innate ability to exercise. And so if we look at a VO2 max of about 89 or 90, an elite Olympic marathon runner, a human, does not have an aerobic capacity of 90, more like 70. And you know, I've run most of my life, my aerobic capacity is probably about 45. So even in their old age, horses have an innate ability to perform aerobically. And if we also look at the velocity at VO2 max, the speed that they're going when they reach VO2 max, the young horse, the velocity is about 10 meters per second, and the old horse significantly reduced at 8. So we do see in the horse over the age of 20, a reduction in aerobic capacity and a reduction in the speed at VO2 max. And of course, if we look at the work in watts, that is significantly reduced. But things like lactate, hematocrit, there is no change in those non-aerobic exercise parameters. Now, let's look at some of Cindy Beatros's work, the effect of aging and training on cardiopulmonary function in this case, standardbred mares. I want to orient you to these couple of next figures on, again, these are the groups of 3 different age groups of horses. On the x-axis, we have our young horses, our middle age, remember the mean was about 15, and the old horse, 27. On the y-axis, we have VO2 max, oxygen consumption in milliliters per kilogram per minute. The black bars are our pre-training values, and red bars are our post 12 weeks of training means of VO2 max. And what we see in the young and the middle age horse, there is no difference pre-training in VO2 max in these 2 groups of horses. And when we look at the old horse, there is a significant reduction in VO2 max. Okay, and so the old horse is significantly reduced compared to the young and middle-aged horse. After 12 weeks of exercise training, we see an increase in VO2 max in the young and middle-aged groups of horses, and we also see an increase in the older horse. So while the older horse is still significantly reduced after exercise training, after 12 weeks of exercise training, they still can improve their aerobic performance. But good news here is we did not see in aerobic performance a difference between the young and middle-aged groups of horses. And as you would expect, the velocity at VO2 max, that certainly improves with 12 weeks of exercise training, even in the older horse, but the older horse is significantly reduced in compared to the young and middle-aged horse. So a take-home here, the aerobic capacity of the older horse is less than it was when it was younger, and it cannot perform as fast as it did when it was younger. Now, let's talk a minute, something of importance to human health as well as equine health. What happens with the thermoregulatory ability in young and old horses during exercise? We did not know the answers to this until Dr. McKeever and his students conducted this research. And very simply, in this first figure here, we're looking at heart rate, and the black bars denote the young horses, and the red bars denote the means of the older horses. At rest, there was no difference in heart rate in the young and old horses. We measured the heart rate at body core temperature of 40 degrees Celsius. And what we see is there's a significant increase in heart rate at 40 degrees C in the old horse compared to the young horse. So what does this mean? The older horse's hearts needed to work harder to maintain the cardiac output needed for blood flow to the muscle to keep that work going, and also to the skin to be able to have the animal thermoregulate. So this definitely suggests a lower cardiovascular and thermoregulatory efficiency, similar to what we see in aging humans. Good news though, folks, 10 minutes after the exercise stopped, the old horse was able to recover equally to that of the younger horse, that there was no difference in heart rate 10 minutes after that bout of acute exercise. And if we look at the time that it took to reach 40 degrees Celsius, the old horse got there much faster than the younger horse. And so in exercising horses, they heat up and cannot thermoregulate much faster than their younger counterparts. So Dr. McKeever also had the question, if the horse's heart had to work harder, cardiac output. Cardiac output, ladies and gentlemen, the formula is very easy. Cardiac output is the stroke volume, the amount of blood that your heart pumps on one beat, times heart rate. And so if heart rate has to keep going up in these older horses, we would hypothesize that stroke volume is reduced. And so Dr. McKeever did the experiment to answer that question. And what we see here, and Maggie Romano, this is one of your wonderful mares that you donated to Franzia all those years ago. And what we see is the plasma volume and resting blood volume is significantly reduced in the older horse compared to the younger horse. So that question was answered. The old horse's heart has to pump many more times to achieve the cardiac output that the younger horse does to get that work done, because its stroke volume is reduced. So in summary of this section of the research of cardiovascular function, aerobic capacity, and training, we know that there is decreased maximal cardiac output, which may contribute to the age-related decline in VO2 max in the horse. A reduction in heart rate max would reduce maximal cardiac output. The speed at VO2 max and maximal speed are reduced with age. Middle-aged horses do not differ from the young horse. Other indicators of work are not changed with age. Older horses cannot thermoregulate as well as younger horses, but training and conditioning can still improve aerobic performance. And this was the first body of data, ladies and gentlemen, that started to suggest that horses in their late teens did not start to show physiological changes in function due to aging. And that when we started to use horses that were over the age of 20, we started to see these changes. So our take home in this section is be cautious when exercising older horses on days like we've been experiencing in hot, humid weather. Take them out early in the morning, take them out later in the evening after the sun goes down. Horses in their teens are equal in their aerobic capacity compared to young horses. Old horses perform at reduced speeds, but The good news for older horses is that they still can get fit and they still can improve their aerobic capacity. So Ms. Weinert, if there are any questions at this point, we can entertain a few of them right here before we go on to the next section.
We actually do not have any questions in the chat quite yet.
Okay.
But if anyone has any questions, we can take some questions now, or we can move on and save them for later on in the presentation.
Yep. We'll keep on going then, Jen.
All right.
We're on a roll. So now we're going to move on to some of the body composition data and some of the hormonal data, which is impacted with age. So again, guys, I'm sharing with you clusters of research experiments that we've done that will have eventually brought us to the conclusion that horses start to show changes due to age once they reach 20 plus. This is a great table, I think. This is a group of the 3 groups of horses, young, middle-aged, and old, and the effect of 12 weeks of exercise training on body composition. And again, 7 years of age, 15 years of age, and 27. They started all at the same body weights. They were not significantly different before 12 weeks of exercise training in their rump fat thickness, which was measured via ultrasound, or their percent body fat percentage. The older horse tended to be higher numerically, 13% versus 11% in the young horse, but that was not significantly different before 12 weeks of exercise training. But look at what happened after 12 weeks on the equicizer. Significant reduction in the old horse in the thickness of body fat as well as percent body fat. The old horses went from 13% body fat down to 9 in 12 weeks. That is highly significant. And ladies and gentlemen, as we move forward through the talk, when we start to talk about inflammaging, remember this, that body fat and obesity is detrimental when it comes to talking about insulin resistance. And so this was a significant finding that the older horse was able to reduce by 4% its body fat after just 12 weeks of exercising 3 to 4 days per week for 30 minutes at each session. That's not a lot of exercise. Now to one of my favorite topics, and that is the discussion of cortisol. I mean, I've studied stress in horses for a long time, and we all think of cortisol as the stress hormone. And in stressful situations, whether it be psychological stress, whether it be physical stress, cortisol being elevated for a long period of time and consistently is detrimental. But in short term, cortisol is important. And so with exercise, we see an increase in cortisol, and it's important because it mobilizes energy stores. It increases fat breakdown. It increases at the level of the liver production of glucose, which then is carried in the blood back to the muscle, where it then is restored as glycogen. And so glucose is the substrate that results in replenishing that muscle that's using glucose to actually work. And so we want, with exercise, to see an increase in cortisol in the short term because we want to be able to replenish that muscle glycogen down the road so that the horse can recover and come back for another bout of exercise. But importantly, cortisol also is very potent as an anti-inflammatory agent. And so if you are going to recover from exercise, you want some cortisol to be able to reduce any inflammation so that you can recover more quickly. So it mobilizes our energy stores so you can replenish that tired muscle, and you also want its anti-inflammatory properties so that you can actually recover from that exercise. And so what I'm going to share with you here is some data looking at plasma cortisol concentrations after acute exercise, either before the 12 weeks of exercise training or after. And what we see is the old horse data is depicted as the gray line. We have time on the x-axis and cortisol concentration on the y. The young group of horses is depicted in the red line and the middle-aged horses in the black line. And what you can all very easily see is that while the young and middle-aged group of horses mount a cortisol response within 5 minutes of exercise, that remains elevated up to about 40 to 60 minutes after exercise. There's no difference in the young and middle-aged group of horses. The old horse responds very minimally to exercise with an increase in cortisol concentration. So we're looking at 70 to 90 nanograms per mil. Very, very small increase, and it does not increase after that. It just is a plateaued line. So the older horse does not mount a cortisol response after exercise, which is unfortunate because we in the previous slide shared with you that we want cortisol because it mobilizes energy stores and reduces inflammation. So what did we see after 12 weeks of exercise training? Again, elevation in both the young and middle-aged horse, which lasts for about 40 minutes. We see a slight numeric increase in plasma cortisol. So some of this non-responsiveness by the older horse is ameliorated with 12 weeks of exercise training. However, it nowhere near comes to what we see in the young and middle-aged horse. So in thinking about recovery for your older horse, not only can it not perform aerobically to the extent that it did when it was in its young age or its teenage years, it cannot recover as quickly as the young and middle-aged horse. Any questions yet, Jen? If we're talking a little bit about body composition there.
Yes, we did have one question here from Margie. She asked, would you suggest a simple other day 20 to 30 minutes for a 22-year-old? How much walk versus trot?
I would start certainly warm up and cool down, but I would ask the horse to trot and ladies and gentlemen, let the horse tell you when it starts to get tired. You will know it. I'm assuming you're riding it. You're not using a heart rate monitor, et cetera, Margie, but I would let the horse trot, 10 minutes, walk 10 minutes initially, but you might get to the point in a 20-minute session that you are absolutely, with conditioning, able to trot that horse with a warm-up and then, a 1 or 2 minute cool down for almost the entire 20 minutes. That's a great question, but let the horse tell you. A 22-year-old horse should be able to do this very, very easily. Okay, I'm gonna move on to one of my favorites now. So I take credit for introducing Dr. David Horhoff, my dear friend, who is the chair of the Vet Science Department at the University of Kentucky's Gluck Equine Research Center, getting him involved in horses. He's a wonderfully trained immunologist. He has a Ph.D. actually in entomology from Penn State University, but he was on the faculty at Louisiana State University when I first met David and got him interested in horses. And ladies and gentlemen, because the University of Kentucky does not have an equine exercise physiology lab and a high-speed treadmill, when Dr. Horhoff, Dr. Adams, and their students want to use exercise in looking at immune response in horses, they have to come to New Jersey. So we get to see them on a regular basis because of the facilities that we have here in New Brunswick. But this was some data that David did when he was on sabbatical here in 1997. And it really does first work that shed light on the fact that horses have a reduced immune response. And so I'm just going to show you two figures, folks. First, we are looking at cell-mediated immune function. So there's two parts of your immune system: cell-mediated immune function, your T cells, your B cells, that actually fight off infection, pathogens, etc. And then, of course, you have your antibody production, your humoral side of your immune response, where the cells actually produce antibodies. And what we see here, young horses in red, old horses, the means, in black. This is the response of T and B cells, lymphocytes, in response to mitogenic stimulation. And what we see is there is a significant reduction in the ability of these cells to grow and proliferate compared to the young horses. And I'm forgetting, ladies and gentlemen, what the mean ages were in this group. I would say it would be about 25 for the old, and again, about 7 for the young horses. Interestingly, though, we also gave them a vaccine challenge, and we looked at antibody production in response to equine influenza virus. And this is before exercise training and after exercise training. The young horse antibody response is shown in the yellow lines, the old horse in the red lines. And what you can very clearly see is that the old horse has a marked reduction in antibody production compared to the younger horse. Now, fortunately, this is not further impacted by exercise. So these lines are almost right on top of each other, but you can see that there is a reduction in the ability to produce antibodies in response to a vaccine challenge in the old horse. And so one thing that has never been answered, and I've asked David repeatedly, and I've asked vaccine companies repeatedly, why do you not do the research to say, so what do we need to do about this? Do you need to vaccinate the horses more often? So twice a year possibly versus once a year? Or do you need to increase the amount of vaccine that is given at a given time? And we don't know the answer to that, ladies and gentlemen, but I can share with you that in managing Lord Nelson for Mr. Manos all those years, especially in New Jersey where we have mosquitoes late until the fall, Lord Nelson would be vaccinated for West Nile, Triple E, twice a year, but I wasn't going to take that chance. Tetanus and things, rabies, once a year was okay. But again, we see in response to, in this case, equine influenza virus, there is a marked reduction in the old horse, his ability to mount a antibody response to that challenge. So think about when you're vaccinating your older horses about possibly talk to your veterinarian and ask him or her about their plan for managing vaccinations for this old horse, because there definitely is a reduction in immunocompetence. So in summary here, advancing age in horses is associated with a declining general well-being. We saw that, in body composition, percent body fat, etc. However, horses do have an innate ability to exercise even with advanced age. Older horses do have a lower cardiovascular and thermoregulatory efficiency. And we have demonstrated that exercise does improve the body composition, a reduction of percent body fat by 4 percentage points after only 12 weeks. So exercise does improve the body comp of the older horse. Training does improve mechanisms that promote exercise tolerance and recovery, especially those that are impaired by age. So for instance, cortisol. And we have shown both from a cell-mediated and humoral side that the older horse is immunocompromised. So you need to visit with your veterinarian about the care of that older horse. All right, I'm going to keep going, Ms. Weinert. one slide here, we did a lot of work in with my postdoc Raul Christensen and master student Patrick Gornalda. Patrick, rest your soul. Patrick passed away at a very early age several years ago, and we miss him terribly, but this was his master's thesis project of looking at the effect of growth hormone on the well-being of horses. And we do know, ladies and gentlemen, in people, in rodent models, a lot of wonderful, elegant work by Keith Kelly, that growth hormone is reduced in older people. We wanted to see if this was also true in horses. And of course, the mediator of growth hormone's influence is the hormone insulin-like growth factor 1, IGF-1. And this is what builds muscle. And it also influences bone development. So we had a contract with a company who produced a recombinant equine somatotropin. And we had, again, these groups of older horses. We gave it for 84 days. This was an injectable every day. And we hoped that it would improve immune function, because we know it does improve immune function in older people, and it also improves muscle mass in older people. And so with a lot of nutrition trials assisted by Dr. Ralston, we saw that there was an improved nitrogen balance, an increased digestion of protein and fiber, which is good, decrease in urinary nitrogen, so the horse was excreting less, and there was also a decreased blood urea nitrogen. So there was less blood urea nitrogen urea nitrogen in the blood. So where did that nitrogen go? And so we have a picture of that fabulous non-cheater trotter mare, the 30-year-old Chablis, pictured here, and after 84 days of growth hormone therapy. I mean, she looked fantastic. She looked absolutely fabulous. But disappointment to Patrick, it did not improve immune function. It did not affect aerobic performance, which we were hoping for, so that we could, that it wasn't a performance enhancing agent, but it certainly helped digestibility and improved nitrogen balance in the older horse. Now, conversely, after taking the horses off the growth hormone treatment, within about 2 to 3 weeks, they went back to what they were looking like before. Older, flabby, skin tone not that great, shine not there, no more dapples, etc. So I know the company is no longer in existence. It is not on the market anymore, but we did the initial trials for Brisagen to show that equine somatotropin therapy did have these effects. All right, we're coming to the finish line. Let's look at the effects of age and acute exercise on mediators of inflammation in horses. And so, I mentioned early in one of the first slides, this term coined by Dr. Horohoff and his Ph.D. student, Amanda Adams, who's now a faculty member at the University of Kentucky on her own. Aging and obesity and inactivity, sitting in a rocking chair, couch potato, okay? This results in increased mediators of inflammation. You have an increase in the circulation of inflammatory cytokines in the body. This has been shown to be one of the major causes of insulin resistance, a reduction in insulin sensitivity. And with an increase in insulin an increase in insulin resistance, you just have this vicious cycle. You then have a horse that becomes obese, that starts to show signs of equine metabolic syndrome, these different fat pads around its body, and this is just a vicious cycle. So can we break this somehow and change inflammaging? I'm going to share with you in the last couple of slides. And we don't know the answer. The question that I just brought up here, how does exercise ameliorate this cycle? I'm going to share with you some data from Dr. Adams that shows the impact that diet has on this. But because Amanda does not have the treadmill at the University of Kentucky, she has not yet been able to answer this question. So I think she's just going to have to come back for at least a year on sabbatical to New Jersey and use our treadmill. This is a complex image, ladies and gentlemen, but the message here is very clear. We're looking at inflammaging in horses as measured by pro-inflammatory cytokine, messenger RNA, and protein expression in blood. Again, let's just keep it simple. We're going to look at pro-inflammatory cytokines. And in this case, we have interleukin-1 beta, interleukin-15, interleukin-18, interferon gamma, and TNF-alpha. I mean, many of you know when you get sick, when you get the flu or something, you don't feel well because you have an increased concentrations of TNF-alpha. But what we can see, the black bars depict the means of the old horses, and the white bars depict the means of the younger horses. And other than interferon gamma, where there was no difference between the old and the young horse, you see a reduction in these inflammatory cytokines in the young horse compared to the old horse. And this is also depicted here in this right panel when we look at actual protein of TNF-alpha. There is a reduction in TNF-alpha protein in the blood in the young group of horses compared to the old. So again, we're starting to see in this term called inflammaging, there's an increase in inflammatory cytokines in the old horse compared to the young horse. Again, if we look here in the left panel, we're looking at percentage of interferon gamma or TNF-alpha lymphocytes or monocytes. That really doesn't matter for this discussion. But what we see, ladies and gentlemen, is in looking at groups of young horses versus old horses, there is a reduction in inflammatory cytokines in the young group of horse compared to the old. Or conversely, we can say there's an increase in inflammatory cytokines in the old horse versus the young. So Amanda asked a very interesting question. And she has, at the University of Kentucky, there are about 400 research horses there to choose from. And she has about 40 older horses over the age of 20. And based on all of the data that we've all collected over the years now, we have said that a horse doesn't start to show signs of old age until it gets to at least 20. So she broke out and she asked the question, is it just a function of age? Is inflammaging just a function of age, or does body composition also have an effect? And so she studied inflammatory cytokines in old horses that were thin, like a body condition score of 3, versus older horses that were fat, a body condition score of 8+. And bingo, what did she find? When we look at TNF-alpha, there is a significant increase in that pro-inflammatory cytokine in older horses that were fat compared to older horses that were thin. So it's not just an effect of age, it's an effect of body composition as well. And so again, going back to that table that I liked so much that showed how much body fat an older horse lost with 12 weeks of exercise training, this fits right into Amanda's work that shows that it's not just old age, it's your body composition that's also important in dictating your state of inflammaging. So Dr. Adams took this one step further and she thought, okay, I'm going to keep these old obese horses on a dietary restriction, caloric restriction diet for a time of 12 weeks. And lo and behold, what she found was after about 10 weeks on a calorie-restricted diet, these older horses started to show a significant decrease in inflammatory cytokines. And then after a period of a couple of weeks, she put them back on a higher caloric diet, and right away, after 5 to 6 weeks, they went right back up to where they were beforehand. And so, guys, we see that dietary restriction, the importance of how much food your older horse is intaking, what its body condition is. And we don't know the answer to this yet. How does exercise combined with a diet impact the horse? And my prediction would be that we would see a reduction in inflammaging in the older horse that's on a restricted diet and is getting also regular exercise. So, in summary, aging alters the pro-inflammatory cytokine, messenger RNA, and protein expression in peripheral blood. It also has an effect on our interferon gamma and TNF alpha positive lymphocytes and monocytes, which is affected by body condition. Dietary restriction and intake does alter the cytokine producing immune cell frequency, and IL-1 beta expression is altered by acute exercise, which is blunted with age. And exercise for horses is necessary for continued well-being with advancing age. Take-home message, folks, regular training is beneficial to horses by allowing them to better tolerate acute stressors such as maximal exercise, and old horses can still adapt to increasing exercise demands and gain the benefits of regular exercise. Here's a picture of yours truly aboard Lord Nelson. This is before he became, he was owned by Tom. This is in the days before we had the equine exercise physiology lab. And so when we used Nelson, who was on the mounted patrol at the time, during our horse management seminars, if we were doing things like looking at lactate and heart rate, we would put the monitors on him and I would gallop him around the college farm road fields and we would take those measurements. Unlike the sophisticated equipment that we have right now where we can put indwelling catheters and everything on these horses and run them at high speed in real time. But Lord Nelson, you were wonderful. You were probably only about 18 here. Here's a picture of Lord Nelson at age 39 when I took him to the State 4-H Horse Show's 50th anniversary celebration at the Horse Park of New Jersey to celebrate equine science for kids. And he was a handful that evening because he hadn't been off the farm in 10 years and he wanted to go back to the trailer and go back home. This was a wonderful group of students who were working on this project with us. All of these young people are either veterinarians or PhDs working in scientific fields right now, did their work here at Rutgers with horses. Charlie Kearns is a PhD who also did a postdoc with me. All of these young ladies are veterinarians in different places around the United States. And shout out to the dear departed Patrick Rinaldo, who did so much of this work and left us way too early. So, ladies and gentlemen, reach out to us at esc.rutgers.edu. I hope you enjoy the rest of these webinars. Come and see us every other Thursday evening. Jen has done a great job at getting some of these wonderful speakers together, which include Dr. Serafin, who's going to do something on biosecurity. We have Dr. Cahoon, who taught acupuncture in veterinary school. 2 veterinarians will be doing a acupuncture lecture for us. And Ed Wingren is going to be talking about farmland issues, preservation, right to farm, etc. And then, of course, on November 5th, our panel of experts. So you can ask, you'll have at us, and you can just type in your questions on any topic. We'll have Dr. Figaro with us, a veterinarian with us, and we're going to have great fun this fall. So love you all. Can't wait to see you soon. Thanks for joining us tonight. And I'll turn it back over to Ms. Weinert.
Hi, thanks, Dr. M, for that great talk. We actually do have some questions from the chat, so I'm gonna share those with you. Margie wants to know, in terms of thermoregulation, does it also mean that winter temps, older horses can't keep warm?
Correct. It's an excellent question, Margie. So the answer is, during exercise, certainly the heat does impact the older horse, but older horses do not keep warm, thermoregulate as well in the wintertime. And so you might have to watch their body language. Are they shivering? Again, a great thing, Jen, I think would agree with this, is to make sure they have plenty of forage, which will increase their inner body temperature. But Margie, you are correct. So you've got to watch your older horse in the different ends of the thermal spectrum, whether it be cold temperatures versus hot temperatures. Thank you for that.
All right, great. We have another question from Kathy Lewis. She wants to know, with regard to the exercise studies and findings, how this might translate to horses with Cushing's disease.
I would imagine, Cushing, again, a metabolic type of disease. And again, that might be a question for Dr. Frigaro and maybe Dr. Williams, in the Ask the Expert section. But I can't imagine that this would not affect a horse with a metabolic issue like Cushing's.
We have another question from Elizabeth. She wants to know, if you had a very fit younger horse that remains in work into their 20s and is still in work 6 days a week, still light jumping 2 feet or less with consistent work and routines, do you think this horse could continue light jumping if done for short periods and maybe only 2 to 5 jumps twice per week? Also, is there a supplement for the extra cortisol that would be safe?
There is not a supplement for the extra cortisol. And Dr. Leibert's work showed that the whole HPAA axis, that the reduction in cortisol is not coming from a problem with the hypothalamus or the pituitary, it is at the level of the adrenal. So the adrenal is just not putting out as much cortisol as it normally did. I would not recommend or start to fool around with a very potent glucocorticoid, which would be dexamethasone. You certainly could increase, the anti-inflammatory properties. And again, if your horse was not recovering quickly, if it was sore, a lot of people do give dexamethasone as an anti-inflammatory agent, but it's about 10 times more potent than cortisol. I wouldn't just start using it as a supplement. And again, when you give exogenous dexamethasone, you will then further reduce the endogenous secretion of cortisol. So dexamethasone will actually block the normal release of what cortisol the older horse still has. In your first part of your question, I think, we've shown, especially in these former racehorses, that with exercise training, these standardbred horses do, even with a stopping, just becoming a couch potato for 12 weeks to 6 months, they bounce back very, very quickly. So their body, their muscles actually remember, the memory is there, and they need very little training to come back to the level that they were. If you have an older horse that's jumping and you're riding it 6 days a week, this horse will tell you when it's tired. My motto is use it or lose it. Keep your horses outside, keep them exercising, keep them walking, keep them working. All horses love a job, they want a job. And if your older horse is still able to do these lessons and still jump, please do it. Let the horse be happy. And in work, guys, that we did for years with horses in equine assisted activities and therapies programs, their cortisol concentrations from psychological stress were sky high compared to other horses that I'd studied over the years. And question, I thought, these horses are housed outside. They don't seem to have a stressful job. but they consistently demonstrated high cortisol concentrations. And so this is going back 25 years ago. What I recommended was these horses at some point in their lives had another job. Put an able-bodied person on these horses, and they might not be able to barrel race, you know, in 20 seconds or jump a 3.5-foot course, but they might be able to go over cross rails or do slow barrels. Let them do a couple of days a week, something that they were used to doing to give them that mental decompression that they need, because what we're seeing is that horses in these programs really do undergo stress. And we'll have more results on that shortly, we hope.
Great. One last question here, or we do have a question here. Another question from Margie. She was just curious, and I don't know if you know this or not, with regards to Dr. Adams' studies on inflammaging. Were the study horses on grass or hay only and no grain? Do you know anything about how they were fed in that study?
Great question, Margie. And if I had the paper here, I could read it and answer you. I am sure that, you know, some of the initial studies of Dr. Adams, these horses were housed outside, you know, because I've been at the University of Kentucky's research facility in the farm. So some of that early work that Amanda conducted, those horses were probably on pasture and hay. I would imagine in that last study that I shared with you, with the calorie, you know, the increase in the intake, I'm sure they were probably given some concentrate at that time to, you know, really up their caloric intake. But don't know. Margie, if you want to send us an email or something, you can, and I can certainly send you a copy of Dr. Adams's paper. I mean, they're my go-tos all the time.
Great. So I think that's all for the questions. We did have another question that was from Linda, and hers was also in regards to a horse that had Cushing's, and questions about exercise and anything she could do to improve his overall fitness. And I know that you already kind of touched on Cushing's, and so I did pop the link for the Ask the Experts into the chat. So any of you who had questions about the Cushing's that want a more comprehensive answer, you can go to that link and put your question in, and there's a question form at the bottom of that page, and that'll go to our Ask the Experts inbox, and we'll get you a more comprehensive answer on the Cushing questions, or any questions that anybody has that you'd like to follow up with. If you think of things later on, you can definitely go to our Ask the Experts and submit your question there.
Great, and I see it. Yep, great.
Yep. All right. So I think that is all for Dr. Malinowski. Thank you all for coming and sharing your time with us to hear this great talk. As Dr. Malinowski said, we're going to continue with these webinars every couple of weeks. So in 2 weeks from tonight, we're going to have Dr. McKeever. He is also faculty here in the Animal Sciences Department, and Dr. Malinowski referenced a bunch of his work tonight. But he is actually going to do something a little bit different. So he's going to do a presentation on the history of equine exercise physiology in horses in biomedical research. His talk is going to focus on how the horse has been a key player in basic biomedical research for centuries, and how the research done at Rutgers follows in the footsteps of the great physiologists of the past. So we encourage you all to come back next week. If you didn't sign up for next week when you signed up for tonight, you can always go back and re-register yourself. That registration is open at all times. So we hope that a lot of you come back and join us next week for Dr. McKeever's presentation on the history of the horse.
2 weeks, Jen. 2 weeks.
I'm sorry, 2 weeks. Sorry, I said next week. I meant next time. In 2 weeks. 2 weeks from tonight. I'm sorry about that slip of tongue.
No, you're getting confused between Equine Trivia Tuesdays and
I know, I've got too many Zoom meetings is the problem, but in 2 weeks we will be back with another webinar. So thank you all so much for joining us. And like I said, send any questions to the Equine Science Center Ask the Experts. Kyle also popped the registration link back into the chat. So if any of you aren't registered for next week and would like to, that registration link is in the chat and you can get that taken care of right now.
thanks everybody. Love you all. Can't wait to see you in person.